welcome once again to the worldwide universe of dissimilar metal welding. Alright, we're talking about questions for study and discussion. What is dilution? Does anybody know? Well, dilution is the change in the chemical composition of the filler metal at the weld interface, where they meet with the base metal and deposited layers of weld metal. Okay, so where their fusion is how they fuse together. So the fusion of a filler metal into a base metal of dissimilar materials. So what is the benefit of buttering heat treatable alloys? Well, it reduces the need for preheating or post-heating when we have different coefficients of heat. Okay, so what is the effect on the mechanical properties of the joint if intermetallic faces form in the filler metal? Come on guys, think about it. Okay, so the filler metal would not be able to alloy with both base metals and would be insoluble, brittle, and cause what? Cracking. Alright, so why is thermal expansion of austenitic stainless steel a detrimental factor in welding base metal combinations that contain it? I want you to think about it. Stainless steel, okay, austenitic kind, has twice the coefficient of thermal expansion of carbon steel. So that means it expands more than carbon steel, okay? So when we expose it to thermal cycling, we're going to have an issue, okay? So we have to think about it that way. It's going to expand and contract, expand and contract. That means we can crack. All right. How may buttering be used to compensate for different melting temperatures between two base metals, okay? Well, we know that base metal can be used for different coefficients of thermal expansion or melting temperatures. For example, surfacing metal for buttering may have a melting temperature in between the melting temperatures of the base metals. The buttered surface is then ground, right? And we can weld to the other side. This provides a new base metal, and the properties are closer to the other base metal, and it makes it easier, and that your weld is successful. So this is a weird word. Why are welds chemically inhomogeneous? Well, what is the word homogeneous? Homogeneous means the same. So it says, why are welds chemically not the same? Okay? Well, welding creates not the same in the weld joint. When metals are welded together, the chemical composition of both metals is disturbed and can lead to loss of chemical resistance and corrosion resistance alloys. So it means we're using not the same materials, we can have problems. Okay, English style. Okay, what is galvanic corrosion and how does it occur? So galvanic corrosion is the acceleration of corrosion that occurs due to electrochemical reaction between dissimilar materials. A small electrical current forms, and when we have like an electrolyte, like seawater, okay? And because the ions go back and forth, they keep sharing and going back and forth, it causes corrosion. That's really what it is. So how much ferrite is required on the filler metal to create an acceptable joint between carbon steel and austenitic stainless steel? Okay, guys, this was really a bogus question. Really, we need to match the ferrite to the carbon steel and the austenitic steel to make sure it works. So the question tells me the deposited filler metal must contain a small amount of ferrite within the austenitic mix to prevent hot cracking as the weld metal solidifies and is subject to thermal stresses. So you have to look at what it is. So why are nickel alloys easy to join and vice versa? Well, nickel alloys can be welded to copper because they have mutual solubility. And solubility means what? They have some of the same components, okay? And it's easier for them to work together. So it's a lot of less problems, okay? So can aluminum coated steel be welded to aluminum? $1 million question. Well, it can be welded if the steel is first hot dip coated with aluminum. Okay, so it depends on how it's put on. All right, guys, as usual, take care, ask questions. Bye.